Dear students, welcome to Digital System Design using Verilog class. In today's class, we will be understanding different types of memories. So, in these memories, there are some basic concepts, types of memories, and how do we identify the error and how do we do the corrections in the error. So, let us concentrate on concepts, basic concepts in the memory. Coming to the general concepts, memory is nothing but an array of storage locations. As you can notice from the diagram over here, it is an array of multiple storage locations. Each and every location will be having its unique address. Every location is having a unique address, and every location is having a fixed size. Okay, so if there are n address bits, then there will be 2 to the power of n locations. So n defines number of address bits, so that based on which the memory locations will be calculated. 2 to the power of n locations will be there. So all locations should be of the same size. As you can see, it should be of m bits. So 2 power n is the number of locations, m is nothing but the size of the memory. So 2 to the power of n by m bit memory. Okay, so memory sizes will be defined in terms of kilo, mega as well as giga. If we look at the example over here, 32k by 32 bit memory means 32k is nothing but 2 to the power of 15 is equal to 32k. So n is equal to 15. That means 15 address bits are actually required in order to form this size of memory. So 2 to the power of 15 cross 32 bit. Here 32 bit is nothing but m. All the memory locations here is having the same size, that is 32 bit. So total number of locations is 2 to the power of 15 locations, which is 32k. And the memory size is required or determined by the application requirement. On what application we are working, based on which the memory sizes will be defined. Coming to the operations, basic memory operations that can be done is, as we already know, there will be an address to say which address we are going to store the data in the memory, and also data input in the form of D. Enable is also there. Read and write operation has to be performed by enabling this pin, and at the output side there is D out. So what is write operation here is, we have to make enable equal to high, WR, that is write operation is equal to 1, and when we provide the data input, that data input will be stored into the memory location specified by the address A. Okay, so whatever the address that is given, into that address data input will be stored. So read operation is, we have to keep enable high, write operation should be made low, that means it is read operation. Now we will be getting data out in the form of D out. We will be getting the data out from the memory specified by the address. So what data we want, that address we need to give, that data will be fetched from the memory and it is given in the form of data out. So these are the two operations that will be done in the memories. One is write and another one is read operation. Write is going to store the data into the memory. Read operation is fetch the data from the memory. Fetch the data from memory specified by the address A. Right? So these are the two basic operations that will be done in using memories. Next is, suppose if I want bigger memories, how do we accomplish that? Is, rather than manufacturing a bigger memories, which is it is not a cost effective solution. Instead of that, we can build a bigger memories by using a smaller memory components, like into 1, into 4, into 8, 16, 32, 64, like that. fixed size memories is available. By using that smaller memories, it is possible for us to construct the bigger memories or wider memories. So we have to use memory components in parallel so that we can make a wider memories. Wider is nothing but from 16 bit 16k by 16 bit, it is possible for us to construct 16k by 48 memory. That is nothing but wider memories. Okay, each and every individual location will be able to store a bigger amount of data rather than only 16 bit. Now it has got changed to 48. How do we accomplish that? Is we have used 16k by 16k by 16 bit memory, so that it has become 16k by 48 bit memory. So as you can notice, D out is 0 to 15 here. The continuation of that is 16 to 31, 32 to 47. So totally 0 to 47 is 48 bit of data we can get as an output. So that input will also be the same size, 0 to 15, 16 to 31, 32 to 47. So 48 bit data is provided as an input, 48 bit data is taken as a output. So you can notice enable is also there, write operation is also there, address is of size 0 to 13, which is nothing but 14 bit. Okay, so this is wider memories. Likewise, if we want more locations, okay, if we want more locations, how do we accomplish that? Is have a look at this example. We have used 16k by 8 components, smaller memories, 16k by 8 memories. We have connected 4 16k by 8 memories. So 16 into 4 is 64. Now it has become 64k by 8. So more number of locations has been generated over there. In the previous example, we have increased the memory and we have made it as a wider memory. Here we have increased the size, number of locations in the memories. Okay, so D out remains 8 bit, D in also remains 8 bit, address is given in the form of 0 to 13 as well as 14 to 15, so totally 16 bit. So 2 to the power of 16, right? And enable is also provided over here. 4 smaller memories of size 16k by 8 has been connected in order to have more number of locations, right? So this is how we can accomplish a wider memory or bigger memories.